Hello, everyone. My name is Dean Marx. I work at the UNH Interoperability Lab, and today I'm going to be explaining how you can set up and run DTS. To begin, let me explain the basics of the DTS use case, system structure, and some terms you should be aware of. First off, DTS is a framework for end-to-end testing of DPDK, where you actually run a DPDK application on your system under test hardware and run some DPDK workload over that hardware. For instance, a majority of the tests in DTS today will start an instance of DPDK test PMD on the system under test network card and transmit packets to that network card for processing. Secondly, there are three entities which I will refer to in this video, which you should understand. The TG, or traffic generator, is a network card on a system I control for transmitting packets in DTS. The SUT is a network card on a system I control for running a DPDK application, and this is where the DPDK functionality is validated. Finally, the DTS engine is the system running the DTS Python application, which is responsible for controlling the traffic generator and system under test over SSH. The DTS application can run anywhere in principle, such as your laptop, the TG SUT nodes, or anywhere else, provided they have SSH access to the TG and SUT. One other possible point of confusion is that the TG and SUT nodes can optionally be two separate physical hosts with NIC interfaces connected back to back, or it can be one individual system with NIC interfaces connected back to back. Ultimately, we just need to be able to start a DPDK application on a network interface, send traffic to it from the TG, and then validate the correct DPDK behavior. With that background in mind, let's get started. First, I'll be walking through the simple Linux setup, which can be found in our README right here. Step 1, on your TG and SUT nodes, add a dedicated user for DTS. In my example, my user will be called dmarx. Step 2, you want to grant passwordless sudo to the DTS user. To do this, you enter vi sudo in your terminal and add this line with DTS replaced with the name of your user. In my example, I'll be using a server called Braum. So if I hop over to my connection over here and run sudo vi sudo, you can see my user dmarx down here with passwordless sudo granted in the privilege specification section. All right, heading back over to my terminal in VS Code. Step 3, we want to generate and copy SSH keys to both the TG and the SUT nodes. An easy way to do this is by running SSH keygen, which will create a private public key pair that you can copy onto your server, and then running SSH copy ID, your user at the server you want to test on. In my case, it will be called Braum. And that's it for simple Linux setup. So moving on, we'll look at this DTS configuration section. There are three YAML files involved: a nodes.yaml, test run YAML, and test config YAML. I'll pull these up here. First, we'll look at nodes.yaml, which contains information about your TG and SUT NICs. This includes host names, users, PCI addresses, and drivers. One important detail: the OS driver represents the kernel driver for the device, and the OS driver for DPDK represents the DPDK drivers, such as VFIO PCI. The test framework will use these values to bind devices appropriately throughout the DTS execution. Test run YAML defines information about your test run, the DPDK source, which test suites you want to run, whether it's a performance or functional test, the traffic generator type, etc., etc. The topology section in test run explains which ports defined in nodes YAML from the TG are connected to which ports on the SUT. There's also a test config YAML file. This allows you to pass in test suite specific parameters, but most test suites don't require this, and it's outside of the scope of this video, so I'll just skip over that. Some configuration values are optional. For example, you can see here I've commented out this huge pages key. That's because I've already set up kernel arguments on my SUT and TG systems to create 1 GB huge pages at boot. However, if I uncommented this section, DTS would create 256 2 MB huge pages on the specified node. When we run DTS, we provide a DPDK source to test on the SUT. This can be an uncompressed DPDK directory or a DPDK tarball. It can also be located on the DTS engine, in which case it will be copied over to the SUT during setup, or it can already be placed on the SUT prior to execution. This behavior is controlled by the remote key. In my demo today, I'll be showing one valid option, which is using a tarball with remote set to false. But keep in mind, this is not the way of doing it, just one example. So here I've already filled out my config with a tarball for DPDK 2503. The important part is to make sure you actually have your tarball copied into your DTS directory. So if I hop back into my terminal, you can see I have my tarball already in my DTS directory. If you're unaware of how to obtain a DPDK tarball, if you go to git.dpdk.org, there are git clone links that you can use and also download links on their main website. So now we are ready to execute DTS through its main.py. In order to do this, we need to meet some dependencies for the DTS engine. That is accomplished through Poetry, which is a Python dependency manager. You are welcome to meet the dependencies on your native system if that is your preference, and you can also use the DTS container, which the repository provides, in order to meet the dependencies, which is the workflow I'll be demonstrating here. So if we scroll back up to this DTS configuration section and run these commands, this one will create a DTS image for Docker. This second one will jump us into that container. We just have to replace this placeholder value with the name of our user. So in my case, dmarx. And once we're in our container, we'll run poetry install, and this will automatically install all required dependencies to run DTS. And once that's finished, we can run poetry run main.py. And as you can see here, DTS execution begins. In my case, I'm running the Hello World test suite as specified in my configuration file. And once this execution completes, the results will be collected in the output directory in both human readable and machine readable forms. I won't wait for execution to finish here, but you'll see them generated there when it completes. And that's about it. You've now successfully set up and run DTS. I hope this video was informative, and thank you for your time.